part G. It says the curvature at any point xy on the graph is defined by. Now I'm going to write this down. So this is all of our working so far. So for part G, we know our curvature, which is an interesting little letter there. Curvature is absolute values of the second derivative of y over dx squared all over 1 plus the first derivative squared and all of that to the power of 3 on 2. So the question then says find the value of the curvature of the graph of f at the local maximum point. So we want to sub in the local max. We know that the local max, I'll put my information here, local max x equaled 3 pi on 4, and we also know that at that point dy dx equals 0 because at the maximum the first derivative is 0, and we also know that the second derivative, we did sub that in somewhere. Here we go. If we sub this in, we're going to get 2 e to the 3 pi on 4 cos of 3 pi on 4, which actually we can simplify. That's just going to be 2 e to the 3 pi on 4, and then cos of 3 pi on 4 is actually negative 1 on root 2, so times negative 1 on root 2, which is, it'll be negative root 2 e to the 3 pi on 4. So if I sub those in, my curvature will equal the absolute values of this. So I'm just going to put that in. Negative root 2 e to the 3 pi on 4. That'll be all over. Now 1 plus our first derivative, which is 0 squared. Well, 0 squared is just 0, so it'll be 1 to the power of 3 on 2, which is still just 1. So what we're going to get is our curvature will equal just the absolute value, so that'll turn this positive, so root 2 e to the 3 pi on 4.